The product true is used to differentiate a function that has two functions that are multiplying. For instance, if you have g of x multiplying with f of x. So if you have these two functions multiplying, you can use the product true. So the product true states that dy dx is equal to, you first differentiate the first function, you find g prime of x, and then multiply it with the second function, which is f of x. Then you say plus, you differentiate the second function, you differentiate the second function, which is just finding f prime of x, and then multiply it with the first function, which is g of x. So this is how you use the product true. Let us take an example. If you have, let's say y is equal to x to the power 3, and then x to the power 3 is multiplying with x squared plus 2x. Then you say this is raised to the power 2. So you have two functions in this case. Okay, let me first remove the 2. Yeah. But for this one, if you want, you can just multiply x to the power 3 in brackets, and then you differentiate it the normal way using the power rule. So let me just put a 2 here so that at least it becomes a bit complicated and at least reasonable to use product true. Okay, so the first function that we have in this expression is g of x. So I'm going to call my g of x as x to the power 3. Then the other function I have, which is my f of x, is just going to be equal to this other part here, which is x squared plus 2x, then everything in brackets to the power 2. So differentiating the first function, which is to find g prime of x, you are going to get 3x squared. Then when you differentiate this one, which is f prime of x, this one, you're going to, when you use chain rule, you are going to get this as your expression, that is 2x plus 2, then multiplying everything by x squared plus 2x. Yeah, so this is what you're going to get as your derivative of f of x rather. So if you differentiate this, you'll get this. So you differentiate this using chain rule. So I've just done it direct here. If you want, you can do it step by step, and then you get to this solution. So you can simplify this further by multiplying 2 in the brackets there, meaning you have 4x plus 4. Okay, let me just write it down. So we're going to have 4x plus 4, then times x squared plus 2x. So this is what we're going to have. So now, using the product true, we're going to combine these two solutions, this one and that one. So we say dy dx is equal to, we first put g prime of x, which is the derivative of g, which is just this part here, which is 3x squared, and then we multiply that with f of x. So my f of x in this case was this expression there, which is just x squared plus 2x squared. So we're going to have x squared plus 2x squared. Then we write our plus there and then multiply g prime of x with g of x. So we say plus, we multiply g prime of x, which is just this, f prime of x, which is just this expression here. So we multiply this expression. So I'm going to multiply this expression with g of x. So my g of x is x to the power 3. So x to the power 3. So this is the solution for the expression there. But if you want, you can factorize it further. Yeah, but this is the simplest. This is not the simplest, rather, but you can factorize it if you want. So this is how you find, this is how you differentiate expression using product true. Yeah, so I'm saying you can factorize it because this part here is common. You have this part, you also have this part, which you can factor it out. Let's see what you can do. So when you factorize there, we're going to have I think even x squared is common. So you can have x squared times x squared plus 2x, and then open brackets. In brackets, we're going to have 3x squared plus 2x. Then you get plus, you have x times, here you get 4x plus 4. So this is the expression I was saying. You can simplify it further. Even this one, you can open the brackets there, also open the brackets there, and then you add the like terms to simplify it. Yeah, so this is how you use product true. Let us check another example. Let's take another example. We see how we can apply it. So let me write another example here. So this example is going to be, let's say you have x plus 1, then you have x plus x squared plus 3 to the, okay, let me say x plus 1 to the power 5 and x squared plus 3. Then you've been told to differentiate these functions. So this is straightforward as well. You do the same. So you're going to say let u be equal to x plus 1 to the power 5. And then, okay, so if you want, you can use u, or you can use g of x and f of x. I'm used to using u, that's why I written u. So let us use g of x and f of x. So let's say g of x is equal to that, and f of x is equal to, yeah, so and f of x is equal to x squared plus 3. So we can now find g prime of x from this expression. So when we find g prime of x, we're going to have 5 using chain rule. You can differentiate this using chain rule. So this will give us 5x plus 1 to the power 4 as our solution. And then this other one, which is f prime of x, will give us 2x when you use power rule, because the derivative of a constant is 0, but the derivative of this will give us 2x. Okay, so we can now plug the expressions in the product rule there, which will just be dy x is equal to. So in this expression, we're going to say our g prime of x is 5x plus 1 to the power 4, and then multiplied by f of x. So f of x in this case is x squared plus 3. Then we say plus f prime of x is 2x. Then we're multiplying this with g of x. So g of x is x plus 1 to the power 5. So this is how you use product rule to differentiate. So the time is almost up. Let me see if we can do quotient rule. Okay, all right. So by the way, this is almost the second, I can say the second last lesson that we're having. But if you are going to insist that we revise the 2 assignments that you had step by step, starting from the first question to the last question, assignment 1 and assignment 2, that will imply that we still have some more lessons to have. But if we are just going to do product rule, and then we do chain rule, rather quotient rule, and then we also come and do differentiation of trig functions, then we're going to call it the end of the syllabus. Yeah, so I think for me, I think we can revise the 2 tests bit by bit. Yeah, I mean the 2 quizzes. Sorry, the 2 assignments bit by bit. Yeah, so immediately after this, I think we will start revising the assignments, because In most cases, they like bringing back the same questions of the assignments in the exam just to check if you understood what you are writing in the assignment. So sometimes they just bring exact questions. So to help us, we're going to revise the assignments. Okay, so on Wednesday, we're just going to discuss the derivative of trig functions and the quotient rule. And then we're done with the syllabus, and then we proceed with assignments. All right, see you in the next lesson. I'm going to send the recorded sessions.
Thank you.